Applications of adsorption. So after understanding what exactly adsorption is, its types, and basically the factors affecting adsorption, let us now study in a very simple way the major applications we have adsorption around us. See, it's a very common phenomenon which is widely used around us in many different ways, like I have listed some of them. Like the first one, production of vacuum. Yes, we can't create vacuum as such, because almost what we find is many gases we find they get still stuck in the vessels which are to be actually converted into a vacuum. So what we do is we put certain substances which absorb those gases on the surfaces, and it really helps in creating high vacuums. Then gas masks. We all know, we have seen the police constables and other people who are actually using gas masks, who are there in that which have to stand in between the major traffic area places. The reason being they are always exposed to very high level of pollution. So in order to avoid that, the mask which they wear is having basically the charcoal which absorbs the poisonous gases on the surface and thus prevents them from getting exposure to these poisonous gases. So gas masks are another major applications of the adsorption phenomena. Then separation of inert gases. Inert gases doesn't react, so you cannot separate them as such by certain chemical reactions. Secondly, they can also not be separated by the help of their physical properties, because again they all are having almost similar physical properties. So how we can separate them? It is majorly is their adsorption. They adsorb differently on charcoal, and that is how they, on the basic of this adsorption phenomena, we can separate these inert gases or noble gases. Then control of humidity. We have seen, as I have told you earlier also, like we have seen silica gel pouches being used in the new shoes which we buy, or the water bottles, or the thermos flasks which we buy from the market. They are usually used to control the humidity. So those silica gel absorbs water and keeps control of the humidity. So that is how, again, silica gel is an example of adsorption adsorbent. So they are very good adsorbents. Then decoloration of sugar. We also know the sugar which we get from the sugar cane is brown in color, and what we do normally is that we pass it through animal charcoal which absorbs it, the brown substance which is there for its brown color, and that is why the sugar which we get is colorless. So it's used in decoloration of sugar. Then heterogeneous catalysis. We know catalysis, the process of increasing the rate of the reaction, and there can be homogeneous catalyst, heterogeneous. The heterogeneous which are not in the same state. So we have number of examples of those catalysts which absorb the reactant molecules on the surface and forms new types of bondings which releases energy, which are used to break the molecules, reactants bonds, and that is how they increase the rate of the reaction, and this is accounted in the heterogeneous catalysis. And the last I have discussed is the chromatography techniques, chromatography analysis. See, chromatography is a basic phenomena which is based on the phenomena of adsorption. The different substances from the mixture gets absorbed at different levels, and this is how they can be easily separated. So the mixtures of different substances can be separated by chromatography technique, by chromatography analysis, and which is mainly based on the phenomenon adsorption. So these are the major few of the applications of the adsorption we have, or which we use in our day-to-day life.